This is Daryl with Hands-On Cisco Training, episode 21. Today we're going to talk about OSPF route filtering and area border routers. In our last episode, we applied a distribute list to OSPF on an interface. So we did not allow a particular route in a interface. But it did not have the impact that we expected. It did not stop the propagation of route information inside the OSPF LSAs. Our OSPF area still propagated all of our routes throughout the area in the LSAs. The only effect the distribute list had was it prevented the route from being installed on a particular interface. However, the routers downstream still thought that they could get to that destination through our router and still sent us traffic, which we then black holed because we did not have a route for that destination. The problem with the applying distribute lists on interfaces in OSPF is that the fundamental design of OSPF is that within each area you should have, every router within an area needs to know all of the information about the area in terms of all of the connectivity of all of the routers, and they all need to have the same information, and then all the routers simultaneously run the shortest path first algorithm, and all of the routers come up with the same answer because they have the same information and they have the same algorithm to determine the route table. But that doesn't work with the distribute list. In order to do route filtering in OSPF correctly, you should execute the route filtering on an area border router and prevent routes from one area from getting into another area. And that's what we're going to do today. We have two areas in our OSPF network for today. We have area 0 and we have area 1. So the middle router is an area border router because it connects to area 0 and it connects to area 1. We have two loopbacks off of the bottom router, and we are going to filter one of the route entries and not filter the other route entry into the top area. So let's start by looking at the route table on our top router, and we should have all of our both of these routes from the bottom router. And here is our route table, and you can see that we have 172.16.5.1/32 as an inter-area route, and 172.16.7.1/32 as an inter-area route. Again, even though they are configured, these loopback interfaces are configured as /24s on the bottom router, OSPF always treats loopback interfaces as /32s, at least in Cisco iOS. So that's the top router, and we have our two routes in our routing table. Let's go to our middle router and take a look at its configuration. Here I am on the middle router. Show run pipe begin router OSPF. You can see that I have my three network statements. Because I had to specify different areas, I went ahead and configured it so that the specific IP address with the IP address 172.16.2.2, where we care about every bit, is in area 0, and that's the serial 1 interface. And 172.16.3.1, where we care about every bit, is also in area 0, that's our loopback. And 172.16.4.1, where we care about every bit, is in area 1. And again, we want to filter, we want to permit the 5 net but deny the 7 net from getting into OSPF area 0. So this is a different syntax that we have to do here. We go into const mode. We have to create what's called a prefix list. IP prefix list, prefix dash list, and we need a name. So let's call it Bob. IP prefix list Bob, and let's put in a deny 172.16.7.1/32, and a prefix list has an implied deny everything at the end. So in order to permit other routes, we need to do IP prefix dash list bob permit zero dot zero dot zero dot zero slash 0. I was looking for an any, but I don't see an any. And this would match the default route. 0.0.0.0 slash 0 would match the default route, but we want to match anything, so we would put we want the prefix list to match to be anything less than or equal to the largest prefix that we can have, so that would be less than or equal to 32, because the largest prefix is slash 32, and we want to permit anything that is a prefix list size less than or equal to 32. And then router OSPF1, and then the way we apply the prefix list is area 1, and we configure the prefix list and we apply it with a filter list. Filter dash list bob filter dash list prefix bob out. So we want to filter networks sent out from this area. So let's see what that did. Show run pipe begin router OSPF. And you can see we have area 1 filter list prefix bob out, and here is our list where we deny the specific route and then we permit any route. Let's look at show IP Ospf Database, and inside area 0 we have summary network link states for 172.16.4.0, which is our serial link. So these are summary LSAs, summary type 3 LSAs, and then we have a summary LSA for 172.16.5.1, which is this loopback, but we do not have a summary for this loopback, which is what we'd expect. Now I've gone back to the top router and done a show IP route on the top router, and you can see that I still have the route 172.16.5.1/32 because it was permitted by my prefix list on the area border router, but I do not have the route for 172.16.7.1/32 anymore. So that route has been denied. So what I've done here is I have successfully applied a prefix list on an area border router to filter OSPF routes between areas. Now let's say I wanted to do something different here. I have in addition to filtering on an area border router, you can do route summarization on an area border router. So let's say here I have a route. Here I have a subnet 172.16.4.0/24 and 5.0/24. And we don't have a 6.0/24 right now, but we have 7.0/24. And let's say, that's 3 route entries in this area. And I could summarize them fairly well by using 172.16.4.0/22, because 4.0/22 has 4 consecutive /24s starting with the 4. So 4, 5, 6, which is missing, and 7. So let's say I want to decrease the size of my routing table by aggregating those routes. Let's go ahead and go to the middle router and we'll remove our prefix list and try to do that. Here I am on the middle router, and I do a show run pipe begin router OSPF. Let's get rid of this prefix list. Conf T router OSPF1 no if area 1 filter list filter dash list prefix bob out. And now if I do a show IP Ospf database, you can see in area 0 I now have a summary LSA for 172.16.7.1, so that route is again getting propagated into area 0. Okay, let's go ahead and attempt to summarize that route. Conf t router ospf 1 area 1 question mark, and then here's the range command. Range 172.16.4.0, and we need an IP mask for the addresses in the range. We need a /22, which is 4 consecutive /24s, so that would be 172.16.4.0, 285.285.252.0. That's a /22, and I think that's it. And it doesn't like that. Let's try don't care. Let's try don't care bits. 172.16.4.0, 0.0.3.285. Yes, I'm making a typo. Conf t router ospf 1 area 1 range. See up above I did the ranty, which of course isn't a valid command. 172.16.4.0 to 0.0.3.285. And we can specify a cost for this. We can advertise it, which is the default, or not advertise the range. Let's hit the default. Maybe it was. Maybe I made a different typo. Conf t router ospf 1 area 1 range 172.16.4.0 285.285.252.0, and it worked. I thought that was what I tried up before. Okay, looking back at my, here I am. Here's my error before. I did area 1 range. I was right the first time with my syntax, except instead of typing 255 here I typed 2555. So sorry about that. Those typos will get you. But I was correct the first time. You do a net mask. So the correct syntax is area 1 range 172.16.4.0. Then you use your net mask, and the net mask for /22 is 285.285.252.0, and there we are. So it's configured. Let's look at our database. Show IP Ospf database. And inside area 0, there is only one summary network link state for 172.16.4.0. But it doesn't tell us what the net mask is here. So in order to see what the net mask is, we have to look at it in more detail. So show IP Ospf database summary 172.16.4.0. And here is that network summary LSA, and you can see it is a /22. And the advertising router is 172.16.3.1, which is us. We are the advertising router because we are the area border router. And there you are. Even though we have 1, 2, 3 subnets in area 1, we're only advertising one summary into area 0. And that's our example for today. So, to review, area border routers are the place to filter routes in OSPF, because inside an area, all the routers should have the complete and identical routing information, so filtering with distribute lists inside an area can result in weird effects. So we created a prefix list on the middle router and applied it so that routes coming out of area 1 were filtered by the prefix list before being injected into area 0 and the rest of the OSPF domain. And then the next thing we did is we configured an area range command so that our 3 subnets inside OSPF area 1 were summarized into one summary LSA inside Area 0. In fact, let's go ahead and look at that summary LSA from the perspective of the... Here we are on the top router, and you can see there's our intra-area summary route, 172.16.4.0/22, coming from the middle router. That concludes our quick lesson today, and that is our last lesson on OSPF for a while. Starting with episode 22, we're moving on to BGP. Again, thank you for watching, and please support these video training podcasts by linking to my website. If you find them useful, other people may find them useful too, and by linking to the website, you help get the word out, and I appreciate that. Thank you.